Hello, my name's Matthew. I'm here to talk a bit about Godot, and I'm going to help you build your first game in Godot. So, let's have a look here. So, if you've never used, I'm going to first talk a bit about. We're going to first talk about building a game in sort of general. So, a game engine, if you've never used a game engine before, we're going to look at. So a game engine sort of defines the parameters of what your game is. This sort of presentation as a whole is for anyone who might have used a game engine before, or if you've never used a game engine before. So if you've used Unity before, you might be familiar with a lot of the concepts here. So we're just going to go over these quickly. So if you've ever played, I presume most of you will have played Super Mario at some point. A very well-known game. Got lots of different components to it, and while it wasn't built in a modern game engine, game engines abstract all these sort of different components. So, for example, in Mario, you'd have a background object, which defines sort of the color and the image that your background might use. You'd have a tile map for the different tiles which Mario is walking on, as you can see. All of them are sort of tiled together, the different squares put together in a row. Mario will be defined as his own object, like a player object. So you'll be able to control him using different controls and stuff like that. The mushroom object will be its own thing. It'll be able to move along the screen and stuff like that. Height might be in its own object because it has collision with everything. They all sort of work, and the game engine defines how all these sort of objects interact and how everything comes together. So, how does Godot do it? Well, Godot does it in exactly sort of the way I described there. But Godot is made up of scenes and nodes. So everything in Godot is a node. For example, your player will be a node in a scene, and the scene contains all of your different nodes. It's a bit easier to explain practically once I get onto that. But for now, Mario, for example, is a node who contains lots of different aspects. So he's the man himself, and Mario contains lots of few different things on his own. For example, Mario will contain a sprite. Mario will have his collision defined because as you fall to the ground, where Mario is at the top and you jump and you go back into the ground, that's his collision. So he'll collide with the floor, and that'll stop him moving in that direction. Uh, and so obviously the mushroom has a similar sort of thing, and you can abstract that for lots of different objects. Depending on the type of game you're building, these can be very simple or very complex. So let's get straight into it. So we're going to open Godot. If you've never used Godot before, you can download it straight from our website. If you're watching this right now and are interested, downloaded it. Godot is absolutely tiny. It's like 40 megabytes, and compared to something like Unity, which is about 500 megabytes, Godot has certainly the speed and the size of a different engine. So if I start it up now, this is what you'll be greeted with when you start a new project in Godot. Ignore my naming conventions; they're very good, I assure you. We're going to create a new project. So it's very simple to create a new project. Just go to Godot here, folder. We'll call this very nice little folder here. Just keep this as it is because this finds the graphics renderer that we'll use, and we only want to use the OpenGL 3.01 usually. We don't really want to use that. We don't want to change that until anything else. So we've created our folder within our Godot library. I should have it somewhere around here. There you go. So now we want to create and edit this project. Here we are. So when you get onto Godot, you'll be greeted with a nice 3D image. We don't want to work in 3D. We're going to create something similar to. If I build, we're going to end up creating something similar to this. So we're going to create a very basic shmup game. And if you're not familiar with shmup games, it's similar to sort of space fighting game. So you have a ship at the side, and it will be firing at different enemies coming at it, and you have to stop them, unless otherwise they'll kill you. Typical sort of game scenario. And in Godot, as you can see, we've been greeted with a screen. Now our screen here has we have the ability to create a new scene. So as you can see here, we have our scene, and we can create a root node for this scene. So that's what everything will be defined from our scene. Let's create a new scene here. So as you can see now, we've got a nice 2D plane as opposed to a 3D one. And we've got a thing. And we can build, as I said before, it's a bit of a tree structure. So when we have a 2D node here, we can make another 2D node here. And this will be branched off this. So your entire scene, which is just one part of the game, will be defined with lots of this sort of tree structure. So for now, we're just going to add some assets to our project. So go to Godot here, tutorial. I'm going to drag in these nice assets I have here. So Godot will automatically add any assets you just shove into its folder, which I find quite convenient. And on top of it being quite lightweight, it makes it quite easy to use and very convenient to use in general. So I have a nice little bit of assets here. So for now, I'm going to call this main, because this is where our main sort of game part of the game will lie. I'm going to save this a folder called scenes. It'll save as main, and as you can see, we have our scene saved to main. You'll be able to understand scenes a bit better once we're creating a few more objects. So for now, all we're going to add is a background. So we can do that simply dragging our back PNG here all the way over here. So now we have a nice sort of background for our game. And we're also going to add a camera 2D. So this is our viewport essentially. So this is what will appear on our screen. We put it here, where we want everything to be inside our thing, and we have it inside of our background object here. When we hit the play button up here, we want to when you run Godot for the first time, it'll ask you to select your main scene, which is why we defined the main scene before. So if you click select and go to wherever your scenes folder is and select this main scene, we have our nice space background. Not quite the game we want yet, so we'll get there. Let's create a new scene now. So as I said, everything is sort of made up of scenes. As I said before, with Mario, Mario is his own scene. So he's made up of his movement and his collision and his sprite. So we're going to create a very similar thing here. So we're going to call this the player. This is the player scene. I'm going to create a sprite. We're going to create. We're going to create. We need an area 2D rather than a node 2D. Not the right kind of area. The reason why we want an area 2D is because we want to define our collision. As I said before, Mario, for example, has this collision defined. Area 2D allows us to define our collision shape, because otherwise, if it was a node 2D, we wouldn't be able to use this. It's a nice clear thing. So we add our sprite real quickly. Ship. Let's use this ship sprite. We drag this into here. You'll notice that over here we have an inspector. So when you select any node, it'll come up with its properties. So for example, a sprite node will have its sort of texture, sprite, and its properties. If we go back here, for example, we've got a camera. Camera will have its own set of properties. So for example, we'll be able to define the zoom level of the camera, the offset of the camera, and stuff like that. Going back to our player sprite, we have our sprite here. We want it sort of facing to the right of the screen. So enemies will come in from the right side of the screen, and we'll be on the left side of the screen shooting at them. So let's have a look. We'll rotate these. Let's rotate it this way. There you go. A nice rotated sprite here. And now you'll notice that we have the sprite itself, and we have this collision shape 2D. Now this declares the bounds for where our collisions with other objects will be. So if we have it sort of roughly the same size of the sprite, then that means we best sort of size for our object. So, a nice capsule here, and a nice sprite here. So now we're going to save this player node to the same folder as the other scenes. And now we can add said scene to the main one. So now if we click play again, we have a nice sprite sitting there. But obviously it doesn't do anything yet because we haven't defined it anything. Going back to the Mario example before, we have to define our movement for a character. So Mario has his movement designed as like an up, down, left, right. He has a type of momentum, but we're not going to implement any form of momentum. So quite simply, we're going to, in order to define different behaviors for nodes, we have to attach a script to this node. So, for example, if we want to define the behavior for this player node here, you can go up to this button over here, and this will attach a script to the area 2D, which is our player. Here we have wonderful little set of scripts, and just the one script. So from the script, we can define the different components for our game. So you'll see already, we've been giving an extends area 2D, which is just because this is the type of 2D. So we're just using all the things that are already in 2D in that sort of type of object. We've also got a function called function_ready, and that just calls when it's essentially the object is added to any scene. So for example, you see that our player here is added. You don't want to add that. You want to keep these on their own, just under main. But you want to, for example, when the player is added here to the scene tree, this is the main node, and these are the things within the scene tree. And so player is added to the scene tree here, and so this function will be called as soon as that is done. There's also another function, which is the one we want to use. That's called func_process. This function will be called every single frame. For example, if you're running your game at 60 frames per second, it'll run 60 times in a second. And in that sort of place, you can check for stuff like input, you can do movement, you can do various different things. And in this specific instance, we're going to define our movement and our input. So let's have a look. So, familiar. It's just press. Right. I'm going to type something here, now I'll explain it. So, here, in this process function, we've defined some input parameters, and we defined our movement. So, as you can see, every single frame, check if the input, which is anything that we press, and the action that the input has just got, the UI down. Now, to be more specific, in your Godot settings, you'll have something called an input map, which essentially just defines all the different little input bits for your program. For example, the ones that are defined by default are the different components for the UI. And those are what you'd usually expect. So, for example, right, up, and down is select, for example, is space. So if you would select on UI, I want that space bar. Up and down, defined as WASD keys, I'm pretty sure. Or the arrow keys. And so you have a lot of different options to do that sort of thing with. You can add your own inputs. For now, we'll just use the ones built into Godot. So, we have our inputs here. And so now, if we save this and run, person has disappeared. That's because they're on the back. Yes. Something specific. You want to take note of how your scene tree is laid out. Something that I just did there. There's a player node here. You can see that the tree goes in like a downwards. You just attach things. You can attach things onto each other. So, for example, I can make this camera attached to the player. So now it would move where the player goes. So if you see the player, you can see the camera 2D. You can see the camera 2D appears here. If I move the player now, I'll move the camera 2D and the player. So we put everything back together and just put this here. Now we have a player on top. So, as you can see, I press up and down, it moves up and down. I just changed that so it's just press. So there's a few different ways you can get input. If action press. So just pressed would mean that it's only registered once. For example, if I press it once and just hold it down, it's only going to detect if it was just pressed. If I have action pressed and hold it down, that means it's going to constantly be checking if that action is pressed. And so this should work correctly now. There you go. Nice and down motion. So, we next want to define, so first we had our player, and now we want to define some enemies for our scene. So, I'm going to create a new scene, 2D node, but we're going to change the type. You can just do that by right-clicking and change type. And change the type to kinematic body. I'm going to add a sprite, not an animated sprite, a regular sprite. As well as the sprite, we're going to add a collision shape. So we have, I'm going to call this enemy. Select collision shape 2D. I'm just going to call this sprite because I changed the name to the wrong thing at first. So let's have a look. So we'll add a different ship sprite for this enemy. So we'll just add this one, I guess. Very nicely. I'm going to make this face the other way. So get you offset. $90. We also want to define a new collision shape for this, so we'll probably use a capsule. This is not as actually no. This is cinnamon. I'm using Linux Mint at the moment, so but I'll most likely be moving to Debian at some point soon. So thank you. Have a look. Got our 2D node here. We've got a collision shape. So now we have both. I'm going to save this. I'm just going to put it in the same folder as the rest of our scenes. Now we have a. You can add this also to our scene as well as everything else. There you go. So now we have our enemy here and the player here. So we got the sprites. Could change the color of that just to look a bit different, make it look a bit more enemy-like. No, it doesn't look the same color as the player. We'll just make it a shade of red. You can change a few different things. If you want to have an explore when you look through different things on the thing. There's like quite a lot of properties on here. So if you ever do test out Godot, I recommend you have a little look through here. Often you won't need every single one of them, but depending on what type of node you're using, there's stuff that you need to use within those sort of areas. So we've got our enemy defined, and now we want to define some new behavior for our enemy. So I'm going to create a new enemy script. I guess Godot has the ability to make cross-platform builds. It does, in fact. Godot is probably one of the best sort of thing for cross-platform, I'd say. It can build for Android, it can build for iOS, it can build for Windows, it can build for Linux, build for Xbox, and build all the major consoles at the moment. It can build for pretty much anything. So that's one of the strengths of Godot. It's really easy to, unlike other cross-platform things that I've used before, like Kivy. That's the only really FOSS one that I've used before. Building is a pain, but in this form, it's a lot easier. So I can show that a bit later. But yes, you can build for pretty much any platform using Godot, or any popular platform using Godot. So that's one of its strengths, I'd say. So I'm going to define some new behavior for this enemy. So similar to the other thing, we want to define some movement. So we can do that pretty easily. We're going to change it again. So we're going to comment this function process. And similar to the one, we can change the position of our node every second. So for this one, since we just want it to move towards the player, we can add some very simplistic AI of just changing the X every, I don't know, every frame by like 5. So this should simply move the enemy left. There you go. Beautiful. So we have a process function, and since that does that, we're all good with the enemy. We don't really need to mess with that right now. But what we do need to do is we can do a number of things now. So we could add the firing at the enemy, or we could add the enemy node killing the enemy, for example. So when it collides, it hides the player and stops the game essentially. So for now, we shall implement the shooting. So we've got some nice missile sprites in here. We're going to use one of them. There's quite a few here. I found a nice open source shmup library that's put in the credits. I'll definitely add that once I upload it to GitHub. So for shooting, we need to add an object for our missile, and then we need to create a missile every time we hit something like spacebar. So first we're going to create a new scene. We can node 2D. I'm going to also make it a kinematic body, like we did the other one. The reason why we're making these kinematic bodies as opposed to area 2Ds is because kinematic body has some different collision abilities than area 2D. So, for example, there's lots of different collision objects in Godot, but these two specifically, area 2D, can get when a node 2D of kinematic body enters into it. Whereas if you have two kinematic bodies, they will have some sort of physics collision, which we don't want because we're in space. So for now, we just want to detect the collision itself rather than handle the collision in a physics way. So for now, a nice sprite, and we'll add a collision shape. So we'll call this missile. So for the sprite, go to our assets. Where is it? We'll use this missile. Okay. And then we'll add a nice capsule for it. So this missile, I'm going to rotate it. Since this is always going to be firing from the player, we're going to rotate it to about 90 degrees. And now we're going to define a nice new collision shape. I think a capsule shape will quite get this one, so we're going to do maybe a circle shape now. Go for a rectangle shape. Make it quite simplistic. Often it won't really matter what kind of collision shape if you're doing these sort of collisions. If you're doing physics collisions, for example, you'll want to be a lot more concerned with the shape of your polygons and how they interact. But for now, since we're just detecting exactly when it'll collide, it's not really much of a bother. So, we're going to miss our scene here. We're going to save it to the same place as all the others. But we can't add this to the scene like we do the others, because player, we want the missiles to be created where the player is. So the missile will shoot out from the player and hopefully hit the enemy. But we can't do that through this menu here. We have to go and define some new behavior. So if we create a new scene for our little Godot script, for our little main script here, we can define a new script. And more specifically, we want to make another input thing. So input dot is just pressed. Have it as just pressed so that you can't spam missiles without spamming the thing. Have that as UI accept. And so we need to make an if statement. So if UI accept, we need to create a new missile object. And the way we can do that in Godot is by looking at our missile object here, and we can add this to our scene here. So we can do that just more specifically by adding this. So what this does is it enables us to pass through a scene, essentially, as it says, packed scene. It enables us to pass a scene through into this script. So you'll see here. Let me just. It won't appear unless you compile. We'll just add a pass function there. You see here that we have our script variables. So we have our missile here. We drag our missile scene into here. So as you can see, it's a very offset image of our missile. So we want to create a new one of these every single time a scene. So every single time a spacebar is clicked. And so what we can do is create an instance of that missile scene every single time we do that. So we can do that by saying var missile equals missile instance. And what this does is this simply creates an instance of this scene here and adds it to this variable. And from that variable, we can add that to the scene. So add child. Since we have this script attached to main here, this will add this missile that we've just instanced to this scene tree as a child of this main bit here. You'll see shortly. We want to set the position of this missile to the same as that of the player. So we can do that like this. So what this does. So if you see this $sign here, this defines something within our scene or existing already. So for example, you can see back, for example, which is the background. I can refer to that by hitting $sign and then back. I can change the sprite of that or something. And that enables you to change the things within that are already existing within your scene. So we have our missile position and our player position. Not quite it. We also need to. We won't connect it yet. We won't do that yet. But for now, I also forgot to define the fact that the missile needs to move, similar to the enemy. The missile needs to move across the screen, but not the same direction as the enemies. It needs to move towards the enemies. So we've got to increase the axis. So position.x plus equals, say 10. So that'll move it x plus 10 every single frame. So let's have a look here. You can see that we have nice missiles every time we hit the spacebar. But they didn't do anything yet, which is obviously a problem. So we can do a few different things. So we want to add a collision with. We want to let it know when each node collides with another. So more specifically, with this we want to let this main function here know when this instance missile, hits any enemy, and that'll let it know to hide the different components. Like it'll know to hide the enemy and hide the missile. It knows it's collided, and so it'll just get rid of them, like they exploded and went away. So we can define that using there's a very useful feature called signals. So, for example, when you have these sort of components on Godot, you can tell when different things happen. So I actually made this the wrong type. This needs to be an area 2D, not a kinematic body, because we need to get when collision happens. And that's what area 2D can do. So we have the cell here, and then we can go over here and select the nodes. So you'll see these are signals. The signals are a concept in the Godot where when a certain event occurs, it'll just run a function. So, for example, if I have mouse entered, when I move my mouse over this area 2D here, it will call whatever is inside that function. When it enters the tree, for example, this is also another signal. When it is added to any scene, it'll call this function and do that. But more specifically, the behavior we want to define here is when something enters the body of this missile. So, for example, specifically, maybe when an enemy enters the body of the missile. We can connect that to here. And from there, we can pass through the different things. So this signal specifically, we want to pass through to the main function. So we can define our own signal, and let's call the signal hit. So we can emit a signal once this is done. Emit signal, emit underscore signal. And so here we have a nice little function that when the body is entered, it'll emit a signal known as hit. So that means that hit something. It will pass through these are parameters here. So these are things that will pass along with it to be able to tell what exactly is happening. So this will pass along what the missile object is, and this will pass along what the body is colliding with, which will be an enemy. So now that we have that, we want to connect the missile scene's signal to a signal in this main function. So if we connect, we can simply do that by missile connect hit. We'll call this function enemy hit. So what this does here is now we're connecting the missile's hit signal to this node here, and we're going to create a function called enemy hit to define what happens when that signal got it. So as we said before, we've passed two things through enemy hit. That's the missile body, which is the self, and missile and enemy body, which is the second part of what we define. If you look over here, we define the self and the body. And so the body, since it's passing through from what's entered, that's what the body we've collided with is. And so you have here, you have a missile body and an enemy body. And so what we want to do with these is hide them. So, as you can see, when they collide, they disappear. And so that is us destroying the enemies. So now we have a very basic game. From that, we can spawn a few more of these enemies. So we can also add time. So I'll do this quite quickly. We can add a nice enemy pack scene instead of spawning them in here. So if I add the packed enemy scene here, I save that. I'm going to add the enemy here. So now I can. What we need to do is we need to spawn lots of different little enemies. So we can do that by defining a initial position. So we've got this position 2D here, which just defines any point in the 2D space. So more specifically, this is just going to be around here. And take note of the fact that this sort of screen is about 600 high. So since it's about 600 high, what we want to do when we create this position of the, oh, not for this, sorry. I'm going to call this spawn position. All this. Right, we need a timer. The timers are a very useful feature of Godot, where you can just define a timer that lasts a number of seconds. Just set it off. Set it to auto start. So you see here, we've got the wait time of 1 second, and we want this to start as soon as it enters the scene. So we just hit auto start, it'll add. And so, call this spawn timer. And so, as we said before, we can use signals to define the behavior of when something does something. Specifically on a timer, we have a nice timeout function. So if we connect that, what we'll have is something here. So now we can do a similar thing to what we did before. So if we just copy and paste it here, because it's basically the same thing that we're doing, but more specifically, we want to replace the same stuff with enemy. So if you see here, but instead of player position, we want it to spawn at the spawn position. So, need to set it specifically to the instance of the enemy. Don't set it to the packed scene or else you'll crash. You want to remember that this is just a definition of the scene. You can't add this to anything. You need to create instances of it whenever you want to use something. You just need to do this line every time when you want to use something. It's not that cumbersome when you do it, and it makes sense. Got to change the other one. And here we have a number. What's that happening is here. Is that when the missile is hiding, it's not disabling the collision. So it'll hide, but it won't disable collisions. So, more specifically, we just want to disable the collision for the thing. So we can do that by using this line right here. So this line here, this has a collision shape, and set the third means that when it's available to be set, when there's in a free frame that it can do it in, it'll set the collision shape to disabled, so the collision shape won't be able to see if anything is happening. So now we do that. To do the same with the enemy. Yeah. We can just do a similar thing. So we define a new function, enable collision. Over here, we can just put the same thing in enemy, because they're the same names for the collision shapes. We can just call this function from when we get the hit. So enemy body, disable, or collision. Do the same for both. For now, you'll be able to successfully kill a stream of ships. And we'll just add a bit of randomness to this. So you can pretty easily create a nice little random variable. You need to get something like v equals random number generator. So this is just a variable that will generate random numbers for us. More specifically, we want to generate a new y position for our form position. So we generate a random float, like, I don't know, that's RNG, sorry. I want to set it to 250 and 250 because, as I said before, you can see that our position is around 200 in the center here. It's about 600 there. It'll be 0 up here. So we can define our nice little random function, go between those 2 points. So now we want to more specifically set the x values and then change the y values instead. So it's not a real thing. There you go. So you can see we've now got a random position defined. So now it goes all over the place. And now we have the most basic game in the world. It should be just about game. How much time have we got left? About an hour. Add some very basic def while we have some time. Made quite good time, to be fair. Obviously, feel free to ask any questions if there's anyone about. I'll be able to. I'm just going to post this as a GitHub link, so people can access it along with the assets. So if you want to just go through and recreate this entire thing, you should be able to. Let's have a look. So we'll add some very basic def. So we want to do a similar thing to what we did before. So, for example, when the enemy is hit, that generates a thing to let it know that it's died. So we can do a similar thing here in the player. So in the player, we can, since it's an area 2D, we can do the similar thing where the body has entered. Specifically, we want the kinematic body of enemy. Connecting from that. we're going to define that. So when the body is entered, we can just do hide, very basic level. This should work. So for example, when an enemy flies into us, we should just disappear. Bizarre. We can still technically do stuff because all we've done is just hidden the object. We haven't really done anything to change the state of it. And so what we can do, we can create our own signal. And we can emit this. And now, since we've got this in a scene tree as opposed to a node, we can actually see our hit signal in here because we defined it in the script, which is very useful. So we can connect this to our main scene on player hit. And now we can display some text, for example. So I want to check and not dead. So we'll make a new function just to tell for dead. So bar dead false, and then on player hit dead was true. And then we can also display some text. So we can add like a very basic node here. Label or something rather. We can make a label. Drag that to the center of the scene. Oh, text is very small currently. We can change that in a second. Line center. Just going to define some custom front properties. So going to font size, we'll set it to like 200. I just want to use. Oh, that's not going to like me doing that. No, it's having a hissy fit at me. This is just some very basic text. Place that in the center. Not there. Come on. There you go. Let me just hide that. And then when we lose, we can just do label show. So you can like set the visibility of any node by just hitting the eye, which is next to it, so like that. And that's just changes the hide property, like we did before for our different things. And so it should do it. The reverse of that, we do it. So it's just show. Yeah. And so now we have probably the simplest game in the world. We can fire enemies and kill them. And we can get hit by an enemy and lose. And that could be your very first game in Godot. Very simple. There are lots of different things you can add to Godot. I mean, Godot has a lot to offer over different game engines. It's a lot more lightweight, for example, than Unity, with a plethora of different things. And the thing about modern game engines is that you can do pretty much the same thing every single one. And Godot does have the edge. That's that it's free and open source. So if there's anything that you want added, and there's a bunch of people who already add stuff and add interesting stuff and fork interesting stuff from it, you can do that. It's super lightweight. So I believe the executable is only 50 megabytes, and like Unity 250 like megabytes, I'm pretty sure, and Unreal is like 20. So you can definitely see some advantages in that. It's a lot more lightweight and efficient, generally speaking. And it's very easy to churn out stuff, sort of just random things, especially like this. I really enjoy using Godot for game jams and things like that. But yeah, this is the most basic game in the world, but it's a game. So, just some closing things. If there's any questions about Godot, using Godot, or any sort of questions, feel free. Um, and yeah, you can feel free to ask them now, but you can also email me. I don't think I can put. Yeah. Put comments in. That's all right. If you're from the school, you can email me on through the Teams chat, or just message me through Teams. My name is Matthew Rimmer, or you can email me at 186-739-02, if you remember that. I'm currently working on a Godot project at the moment called Rhythm Train, which is a research project along with a master's student, where we're testing it to see how effectively we can train music sight reading through using Godot. That's a really fun project that I'm working on at the moment. And so I will take any excuse to talk about or practice Godot that I can get. So if you have any questions or anything, feel free. So, yes. So thank you very much for everyone who came along. I really appreciate you taking the time to watch. And thank you very much.